Evaluating and graphing logarithmic functions. We're going to split this one up into two parts. This is super important that you have written down. This is how we convert or how we can change logs from exponential form to log form. And so again, just notice the base of my log, it becomes my core, the base of my number, my exponent. X becomes my exponent here, and then y is what this will equal. So if we look at maybe an example or two of, we've got logarithmic form and then we've got exponential form. So if I looked at log base 2 of 8 equals 3, if I were to translate this or switch it over, it would be 2 to the third equals 8. So again, here's 2, here's 8, and then here's my 3 right here. And 2 to the third power, as we know, 2 times 2 times 2 does in fact equal 8. Couple other examples, log base 4 of 1 equals 0. Again, any exponent to the power of 0 equals 1. Log base 12 of 12 equals 1. 12 to the first power equals 12. And then log of 1/4 of 4 equals -1. When we convert this to exponential form, we get something like this, which again is a fraction over a fraction. Keep, change, flip, you end up getting 4. Okay, so that can be rewriting. We can also evaluate them. So slightly different. Let's say I want to find log base 4 of 64. What does that equal? Well, I'm going to think about what power of b gives you y. So I'm going to translate it and say 4 to what power is going to give me 64. Well, I know that 4 to the third is 64. Therefore, the answer to log of base 4 64 equals 3. Again, this is what we were trying to figure out. Let's say that we have log base 5 of 0.2. And so again, we say 5 to what power? I don't know. 5 to what power is going to give me an answer of 0.2. Well, that's getting smaller, so I know that my answer has to be a negative number. And I believe if we went 5 to the negative first power, that would be like saying, hey, it's 1/5, which is the same thing as 0.2. So the answer for this one is -1. Again, thinking what power to the if it's 1/5 to what power is going to equal 125. This is that kind of backwards idea where because my answer already is a fraction, I need to use a negative number because this gives me it's like a fraction of a fraction, which we know to solve that, we keep, change, and flip, which gives us 125/1. So the answer for this problem is -3. Think about this as just like a super big fraction bar. So we have I could even make this a fraction on top. 1/1, super big fraction, all over 1/5 times 3. Keep, change, flip. A common logarithm is a logarithm with base 10. So if we say a common log means base 10. So log with a base of 10. And we usually don't write base 10. So we would just say log of x. So if you notice that there's no base number, that means that it's a base 10. You can assume a base 10. We also have something called a natural logarithm, which I'm sure you can guess is going to use base of e. And so log base of e, we actually write as ln of x. So if you can kind of think about it as they cancel out and turn into this. And this is called the natural log. So you can use calculators as well to help you determine what these are. So if I was looking at log of 8 or ln 0.3, I could use my calculator. Let's see here. So one way to do it would be to say, all right, where's my functions? Here's log. Again, we said it was just a normal base 10, so we can just type in our 8 and get an answer of 0.90308 da 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 da. So let's say 0.903. And then natural logs. Oops. Nope. I saw that there was a natural log button as well. 0.3. Negative 1.204. All right, looking at a logarithmic model here. Let's say that the wind speed is called S. And that's in miles per hour. Can be modeled by S equals 93 log D plus 65, where D is distance in miles that the tornado travels. In 1925, a tornado traveled 220 miles through 3 states, Missouri, Illinois, and Indiana. Estimate the wind speed near the tornado's center. So if we take our equation, S equals 93 log D. D in this case is going to be 220. So I'm going to plug in 220 right here and then plus 65 at the end. Let's use our calculator to figure out what log of 220 is. And that's about, let's say 2.342. So 93 of 2.342 plus 65. And when I multiply 93 times 2.342 plus 65, I get 282.806. So the wind speed near the tornado center was about 283 miles per hour.